Here, I'm going to give you more example of how enthalpy change is going to affect the solution formation. Okay, so I'm going to use the water and salt mixture to help you understand this a little bit better. So let's say you have a beaker of water. If you're looking at these water molecules, right, microscopic picture of these would be each of these water molecules are going to interact with each other through hydrogen bonding, right? So now, if you have salt, right, so salt are going to be ionic compounds, right, because contain cation and anion, right? So in this salt, it's going to come from the cation and anion hold each other in a crystal structure form, right? So that means in this case, the bond or the interaction that hold each of these together would be electrostatic force of the ionic bond, right? So it's the bond between ions, between the cation and anion is pretty strong, right? So now, when you add salt to water, what happened then? Okay, so the salt that is added to water, the salt is going to be the solute and water would be the solvent. Now let's take a look at the microscopic picture of ionic compound in water. Okay, so let's say when salt crystal is in water, the first thing that will need to happen is that the ionic compound will need to break the bonds, right? So the bond within the ionic compound will need to be separate in order for each of these ions to separate into cation and anion. And that process is going to require heat. So this breaking bond of ionic compound is going to involve with endothermic process. Okay, so if you're looking at water also need to make space for the ions as well. So therefore, in this case, you will need to also break the intermolecular forces between water molecule, which is the hydrogen bonding, right? So this process also going to be endothermic process. And the water molecule is going to surround the ions of the ionic compound and is going to pull ions one by one. The process in which the solvent surround the solute, this process is referred to as solvation. Okay, so in the solvation process, when water take away each of the ions out of the crystal of salt, it's going to cause the salt to dissolve eventually, right? You are no longer see the crystal of salt anymore, like at the end of the process, right? And the interaction between the water and the ions is what we refer as ion dipole. Okay, so this is come from the partial positive and partial negative of the water molecule to the cation and anion within the ionic compound, which means that the third step of this process would involve with making the new interaction, which is the ion dipole going to release the energy. So the third step is going to involve with exothermic process. If you put all of these together, you will see that when you have salt mixing with water, first step would be breaking bond between solvent, right? And then solute, and then the last step would be forming bond between solvent and solute, right? And the relative energy is going to refer to whether it's come out to be endothermic or exothermic process, right? So the application of this is that you are going to be able to see it in instant cold pack versus instant hot pack, right? Because if the solution come out to give the overall enthalpy of solution to be positive, you are going to end up with the endothermic process, and that is going to be an application of instant cold pack. If the process is end up releasing heat at the end as the overall, right, you are going to end up with the application of the hot pack. So you're going to see more of this example when you're looking at the lab that you are going to deal with the cold pack and hot pack later. Okay, so now if you tie this back into the spontaneity that I mentioned earlier, you will see that for the exothermic, it's going to always happen spontaneously no matter what, right? Because the lower enthalpy is the driving force along with the increasing the entropy as well. However, when you're looking at endothermic process, the small delta H, right? So the overall delta H that you see in blue right now, if it's relatively small, it's still going to cause reaction to happen spontaneously still, because the entropy change still going to drive the reaction. However, if the reaction come out to be a very, very endothermic, it just means that the process will not occur at all, which means that the salt will not be able to dissolve in water. So that's what it means in here.